Welcome to this video on software engineering for robotics. In this segment, we will introduce you to the basics of software engineering for robotics. Robotics is a field that has seen tremendous growth in recent years. From manufacturing to healthcare, from agriculture to space exploration, robots are being used in a wide range of applications. However, the effectiveness of a robot depends on the software that controls it. Software engineering for robotics is the process of designing, developing, testing, and maintaining software systems that control robots. It involves a combination of software engineering principles and robotics concepts. The software that controls a robot must be able to process sensor data, make decisions based on that data, and control the robot's actuators. This requires a deep understanding of the robot's hardware and the environment in which it operates. Software engineering for robotics is a complex and challenging field, but it is also a rewarding one. With the right skills and knowledge, you can design and develop software systems that enable robots to perform tasks that were once thought impossible. In the next segment, we will discuss the key components of software engineering for robotics. In this segment, we will discuss the key components of software engineering for robotics. 1. Perception. Perception is the process of acquiring, interpreting, and understanding sensory information from the robot's environment. This includes data from sensors such as cameras, lidars, and sonars. Perception is a critical component of software engineering for robotics because it enables the robot to understand its surroundings and make decisions based on that understanding. 2. Planning and control. Planning and control are the processes of generating a sequence of actions that the robot must perform to achieve a specific goal. This includes determining the optimal path for the robot to follow, controlling the robot's movements, and adjusting the robot's actions based on feedback from sensors. 3. Human-robot interaction. Human-robot interaction is the study of how humans and robots interact with each other. This includes designing interfaces that enable humans to control robots, as well as designing robots that can interact with humans in a natural and intuitive way. 4. Software architecture. Software architecture is the process of designing the overall structure of the software system that controls the robot. This includes defining the components of the system, their interactions, and the interfaces between them. 5. Testing and validation. Testing and validation are critical components of software engineering for robotics. This involves testing the software system to ensure that it meets the requirements and specifications, as well as validating the system's performance in real-world environments. In the next segment, we will discuss the software development process for robotics. In this segment, we will discuss the software development process for robotics. The software development process for robotics is similar to the software development process for other applications, but with some unique challenges. The process typically involves the following steps. 1. Requirements analysis. The first step in the software development process is to define the requirements for the software system. This involves understanding the robot's capabilities, the environment in which it will operate, and the tasks it will perform. 2. Design. The next step is to design the software system. This involves defining the software architecture, the components of the system, and the interfaces between them. 3. Implementation. The implementation phase involves writing the code for the software system. This includes writing code for perception, planning and control, human-robot interaction, and other components of the system. 4. Testing. Testing is a critical component of the software development process for robotics. This involves testing the software system in simulated and real-world environments to ensure that it meets the requirements and specification. 5. Deployment. Once the software system has been tested and validated, it can be deployed on the robot. 6. Maintenance. The final step in the software development process is maintenance. This involves monitoring the software system for bugs and issues, and making updates and improvements as needed. The software development process for robotics is iterative, meaning that each step may need to be repeated multiple times as the software system is refined and improved. In the next segment, we will discuss the tools and technologies used in software engineering for robotics. In this segment, we will discuss the tools and technologies used in software engineering for robotics. 1. Robot Operating System ROS. ROS is an open-source framework for building robot software systems. It provides a set of libraries and tools that enable developers to create complex robot applications. 2. Simulation tools. Simulation tools are used to simulate the behavior of robots in different environments. This allows developers to test and validate their software systems without the need for physical robots. 3. Programming languages. Programming languages such as C++, Python, and Java are commonly used in software engineering for robotics. These languages provide the flexibility and power needed to develop complex software systems. 4. Integrated development environments IDEs. IDEs such as Eclipse, Visual Studio, and PyCharm provide a comprehensive set of tools for developing, testing, and debugging software systems. 5. Machine learning libraries. Machine learning libraries such as TensorFlow and PyTorch are used to develop algorithms that enable robots to learn from their environment and improve their performance over time. 6. Version control systems. Version control systems such as Git and SVN are used to manage the source code for software systems. This enables developers to collaborate on software development and track changes to the code over time. 7. Cloud computing. Cloud computing platforms such as Amazon Web Services, AWS, and Microsoft Azure provide a scalable and cost-effective way to deploy and manage robot software systems. In the next segment, we will discuss the future of software engineering for robotics. In this final segment, we will discuss the future of software engineering for robotics. The field of robotics is rapidly evolving, and software engineering will play a critical role in shaping its future. Here are some of the trends that we can expect to see in the coming years. 1. The increased use of AI and machine learning. As robots become more intelligent, they will rely more heavily on AI and machine learning algorithms to make decisions and adapt to their environment. 2. Cloud robotics. Cloud robotics will enable robots to access vast amounts of data and computing power, allowing them to perform more complex tasks and learn from their environment in real time. 3. Edge computing. Edge computing will enable robots to process data locally, reducing latency and improving performance. 4. Human-robot collaboration. As robots become more advanced, they will be able to work alongside humans in a wide range of applications, from manufacturing to healthcare. 5. Standardization. As the field of robotics continues to grow, we can expect to see more standardization in software engineering practices and tools. In conclusion, software engineering for robotics is a complex and challenging field, but it is also one that offers tremendous opportunities for innovation and growth. With the right skills and knowledge, you can help shape the future of robotics and create software systems that enable robots to perform tasks that were once thought impossible. Thank you for watching this video on software engineering for robotics.